In this video, we want to cover section 4.4, which is the laws of logarithms. In our first example here, we want to evaluate the expression. And in particular, we're going to evaluate the expression log base 3 of 15 minus log base 3 of 35 plus log base 3 of 63. Well, what do you do with all of this information? Well, when we have logarithms, we have two separate logarithms with the same base, and there's a subtraction in between. That negative here means that this 35 is going to be in the denominator if we combine these expressions. Anytime we see a plus, that means to multiply. So we're going to do that, which is to rewrite this all as one logarithm. So it's log base 3, where we have 15. But then this plus log base 3 of 63 says that we're going to multiply by 63. And this minus log base 3 of 35 says that we're going to divide by 35. So we get this expression on the inside. 15 times 63 divided by 35 becomes 945 divided by 35, which is, this entire expression is log base 3 of 27. Well, now this goes back to the problems that we did in the last section. So log base 3 of 27, how do we evaluate that? Well, we want to rewrite this as 3 raised to the y is equal to 27. 3 is 3 raised to the third power, so y is 3. So our final solution is 3 for this expression. We're going to do a similar problem here. So that was part A. We're going to do a part B. We have a similar problem here, and that is going to be the log of 10 raised to the 100th power. Here, when we don't have a base written, that's assumed to be log base 10. So, what do? If we want to try to evaluate this expression, this is log of 10 raised to the 100. If we have an exponent in here, we can move that out to the front. So this is 100 times log base 10. If we have a product on the inside of a logarithm, then we can separate this into an addition. So this is log base 10 of 100 plus log base 10 of log of 10, which again is base 10 here. Well, what is log base 10 of 10? Well, that is 1. So we're going to rewrite all of this as log base 10 of 100 plus log base 10 of 1. Well, what is this? To evaluate that, again, this is 10 raised to a y is 1. Well, what does y have to be? That means y is 0. So it tells you that this log base 10 of 1 is 0. So this is, in fact, just log base 10 of 100, this entire expression up here. So, what is log base 10 of 100? Well, again, we do that same trick we've been doing, which is to write this as 10 raised to the y is equal to 100. Well, what is 100? That is 10 squared, so y is 2. And that is our final solution. We have a couple of more examples for this section. So number 2 is going to be expand the expression. And A is going to be log base 2 of x times the square root of y. So to expand this expression, notice first that we have x times the square root of y. If we have the multiplication on the inside of a logarithm, again, that separates via an addition. So this is equal to log base 2 of x plus log base 2 of the square root of y. But the square root of y is the same thing as y raised to the 1/2 power. So in fact, this all becomes log base 2 of x plus, if we have an exponent on the inside, we can move that out to the front. So this is plus 1/2 log base 2 of y. And we have fully expanded the expression here. And so that is our final answer. A few more of this type. So the next one's going to be log base 6 of 3x cubed over y to the 4th. If we continue on like we did last time, we have log base 6 of 3. But then this 3 is multiplied by x cubed, so we have a plus log base 6 of x cubed. And then we're divided by y to the 4th on the inside here. So again, that is a minus log base 6 of y to the 4th. Notice for two of these terms, we still have an exponent on the inside, so we can bring that down. So our first term stays the same. Our second term, we bring the 3 down and multiply. So this is 3 times log base 6 of x minus, now we have a 4 in the exponent, so this is 4 times log base 6 of y. We have one more example of that type. A little bit more complicated, but really it's the same thing. So this is going to be log of the square root of x squared plus 2, all divided by 2x minus 3 times x plus 1. And in fact, let's put a 4 on that. So this is square root of x squared plus 2 divided by 2x minus 3 times x plus 1 to the 4th power. And that square root is over that entire expression. So what do we do? Well, the first thing is this entire expression is raised to the 1/2 power. So we can move that 1/2 out to the front. And this is 1/2 times log of x squared plus 2 in the numerator, and then 2x minus 3 times x plus 1 to the 4th, all that in the denominator. Then we continue on like we did in the last problem. This is 1/2 times, now we're going to separate this logarithm into 3 different logarithms. Log of, and this expression up in the numerator, so it's log of x squared plus 2. Now the other 2 are all in the denominator, so this will be minus log of 2x minus 3 and minus log of x plus 1 to the 4th. And again, it was 1/2 times all of that. Well, we have one more thing to do. Notice we have an expression raised to the 4th power, so we need to move that 4 down to the front. Note that we cannot do that here with the x squared because the square is not on the plus 2 part. Okay, if we have an addition in here, we cannot reduce that any further. But here, that 4 is on the whole term, or the whole expression here, x plus 1, so we can drop that down. So we'll go ahead and do that now. You got 1/2 times log of x squared plus 2 minus log of 2x minus 3 minus 4 times log of x plus 1. And this is our expression fully expanded out. Now we're going to do the opposite of that. We're going to combine these expressions. So the first one is 2 times log base 3 of 5 minus log base 3 of x plus 1. First thing we need to do is put that 2 on the inside of our logarithm here. So this is log base 3 of 5 squared minus log base 3 of x plus 1. Well, log base 3 of 5 squared is 25. And then notice that we have 25, and then a minus log base 3 of x plus 1. Minus means that this goes into the denominator. So our entire expression is log base 3 of 25 divided by x plus 1. One more, and that is we want to combine the expression 1/4 log of x plus 3 to the 4th plus 1/3 times log of x to the 6th minus log of x squared minus x minus 12 raised to the 3rd. Here, we want to, again, move this 1/4 up to the exponent. So this is log of x plus 3 to the 4th raised to the 1/4. Well, 1/4 times 4 is just 1, so that'll go away. Those will really cancel. And over here we have plus. This 1/3 distributes, so that goes to the exponent of both of these. So this is log of x to the 6th raised to the 1/3 minus log of, and then x squared minus x minus 12. But again, it's 1/3 times 3 up here in the exponent, so those will cancel. So I'm just going to go ahead and rewrite all of that out. So this is log of x plus 3 plus log of, we have a 1/3 times 6 here, so that's 2. So this is a log of x squared minus log of x squared minus x minus 12. And then we can put all of this, since we have the same base everywhere here, right? Log base 10. Since we have the same base, we can combine all of these into one expression. So this is log of, let's see, x plus 3 times x squared divided by, why is it divided by? It's because we have a negative here out in front. So divided by x squared minus x minus 12. And then let's see if we can reduce. And to do that, I want to factor this and then see if anything cancels out. So we have log of x plus 3 times x squared in the numerator. And the denominator factors to x minus 4 times x plus 3. How did I know that, right? We needed negative 4 times a positive 3 to be negative 12. And we needed the negative 4 plus 3 to be a negative 1. And they do. So we notice that the x plus 3's can cancel. So in fact, this is log of x squared all over x minus 4. And we have combined the expression to simplify it. And that's it from this section.